I'm going to show you how to use Desmos to analyze some of your graphs. We've been talking about parent functions. So let's say I have the parent function. Let's say I have the parent function y equals x squared. If I want to adjust this parent function, I can multiply it by a leading coefficient. I can subtract an h term, or I can add a k term. Now I'm going to create sliders for these. And creating a slider just means that I am able to adjust these values to make them what I want. So right now the parent function is the same as my standard function. A is 1, I have no h, and I have no k. hk is your vertex. In case you, I don't know if you guys have worked on that yet or not, but let's say I take my h value. H value is inside the equation, and I move it to the right, making my h positive goes to the right, making my h negative goes to the left. But notice in your equation that it's minus h. So when you have minus a number inside, it's the h value is actually a positive. So I often say that h is a liar. Let's go back to using my k value. If I adjust my k up, my graph goes up. If I adjust my k, make it negative, my graph goes down. So k on the outside of the function moves the graph up and down, and h inside the function moves it left and right. Well, what about a? My a value stretches or shrinks my value and also reflects. So if I make my a bigger number, my graph gets skinny. If I make my a wider number, less than 1 but also still positive, my graph gets wider. But when I make my a negative, I reflect over the x-axis. So if I just had a negative 1, not multiplying by any number, my graph is just reflected over the x-axis. So a negative is going to reflect your graph, and a positive is going to be straight up, but you might have some sort of adjustment in terms of, is it going to be wider or skinnier? And this is true regardless of the parent function that I'm talking about. I could be talking about a square root function. My square root function can be moved to the right or to the left using h, and my k moves it up and down, and again my a stretches it or shrinks it in comparison and also does a reflection. When I was asking you guys about creating 2 new points for your discussion post, what I wanted you to notice is that on a standard parabola, there are specific points that are true always. It's 1, 1 is always on a standard parabola because 1 squared is 1, and 2, 4 is always on a parabola that's standard because 2 squared is 4. And then there's the axis of symmetry, which goes through the vertex. Make it a different color so you guys can see it. The axis of symmetry straight up and down. I can mirror those points on the other side of that. So if I went to the left 1, so negative 1, and up 1, that's mirrored on the axis of symmetry. And if I went to the left 2 and up 4, that's also mirrored. So now I can take those 4 points, and regardless of where my graph is, let's say that my parent function is now, I have taken, let's say I have x squared plus 1, or plus 2. So I moved my graph up 2. In order to move those points up 2, from the vertex, I can take my point 1, 1, and I now can move it to the right 1 and up 1. So I have this point at 1, 3. So from the vertex of 0, 2 now, I can go over 1 and up 1, and over 2, up 4. So wherever you start your vertexes, you can move that up and over those specific number of points.